Hi, welcome to my video on Find the Exact Trig Ratios of Special Rotations, Part 2. And the reference angle for this one is going to be 60 degrees. Find the exact value of cos and sine for each on the unit circle. So we have, the first video, we had a 30 degree angle and a 60 degree angle and a 90 degree right triangle. Opposite to 30 was a half. Opposite to 60 was root 3 over 2. And the hypotenuse, or the radius of the circle, is 1. That's the triangle that I've memorized ever since we started trig many years ago, and is still relevant today. And what about if we have a rotation of 60? Again, the radius of the circle is 1, so this point here is 1, 0, and this is the initial arm being extended. The radius is 1 unit, the center is 0, 0, and we're going to rotate 60 degrees. 60 degrees, let's say, is roughly right there. So that's a 60 degree rotation. We draw a terminal arm going for that rotation, and the angle at the center, which is the reference angle, is 60. We drop a perpendicular to the x-axis, so we have a 90, 60, and this is 30. Opposite to 30 is a half. Opposite to 60 is root 3 over 2. So this point right here, x is a half, and y is, root 3 over 2. And the cos of the 60 degree, cos is the x, and the x is a half. And the sine of 60 degrees, the sine is the y. Remember, the radius of the circle is 1, the hypotenuse is 1. So the sine is the y value, which is root 3 over 2. And I just want to show you a fast way to do it, but it's using a calculator. And clear that. So we're going to do the cos of 60, which is a half. So if I hit, again, the calculator's in degree mode, cos 60 degrees, and I have a 0.5, a half. The sine of 60 is root 3 over 2. And the sine of 60, now when you use a calculator, it won't give you an exact value. A calculator for the sine of 60 is 0.866. That's a decimal approximation. And remember, that is root 3 over 2. Let me clear this and do the square root of 3, division. Notice I put 3 in bracket, close it off, division 2. And so the square root of 3, root 3 over 2, is approximately decimal 866, or 0.87. So that's, you can use your calculator, but when you're doing contests or when you're doing SATs for universities, you need to know about this triangle because you're not allowed to use your calculator. Okay, let's do a 120 degree rotation. 120 degree rotation is all the way around as 90 plus 30 more. So let's say that's a 120 degree rotation. We drop, let's do the terminal arm going out through that end of that point. Rotation, we drop a perpendicular to the x-axis. Because that's 120, that means that this reference angle here is 180 degrees. Subtract the rotation of 120. So this angle here is 60 degrees, which is the reference angle. That means this angle up here is 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And because we're in the second quadrant, the y is positive and the x is negative. So that's a negative a half. So the coordinates of this point are x is a negative a half and the y is root 3 over 2. So the cos of 120 is the x, negative a half, and the y, the sine is the y rotation of this rotation, which is root 3 over 2. And notice just that you get the same value of x except it's positive and negative. you get the same value of y, except positive and negative. Notice in the previous video, we had root 3 over 2 and 1/2. Because we have a different reference angle and they're related, the numbers are switched. Okay, find the value of cos and sine for each on the unit circle. We have a rotation of 140 degrees. And again, just to remind that this point right here is 1, 0, and this is the coordinate 0, 0, and the radius of this circle is 1. So we're going to rotate 240 degrees. So there's all the way around 90, as far as here, 180, and so much more. So how much more? Well, we've gone 240 is the rotation. So that's 180. So we take off 180, we get 60 left. So we draw a terminal arm going out through that rotation, 180. So this angle is 60. Drop a perpendicular to the x-axis, and that makes a 60, 90, and this is a 30. And again, opposite 30 is a half. Opposite 60 is root 3 over 2. And because we're in the third quadrant, the x is negative, so negative a half. The y is going down, so that's negative root 3 over 2. So the x is a negative a half, and the y is negative root 3 over 2. And the cos of 240 degrees, the cos is the x, which is a negative a half, and the sine of 240 is the y, which is a negative root 3 over 2. And check with your calculators. If you use your calculator on the cos of 240, you get a negative 0.5. If you use the sine of 240, you get a negative 0.866. Okay, let's continue. What about the rotation of 300 degrees? So 300 degrees is all the way around the circle. 90, 180, 270, and so much more. How much more? Well, how much more do we go in here? Well, let's see. If we go all the way, which is right to here, 360, and we subtract the 300, what's left to rotate? That means that if we go as far as here with this rotation, so this, let's go back up here. This rotation, just put that rotation, just reminded me I didn't put the rotation in 240. The rotation here is 300 degrees. That means we draw the terminal arm. So what's left is a 60 degree, and that's your reference angle. Perpendicular to the x-axis gives us a 30 degree angle here, and 30, 60, 90. So opposite 30 is a half. Opposite 60 is root 3 over 2. And in this quadrant, the fourth quadrant, the x is positive, and the y is going down as negative. So the coordinates of this point on this 300 degree rotation, x is 1/2 positive, y is a negative root 3 over 2. And the cos on the unit circle whose radius 1, cos is the x, which is 1/2, and the sine of 300 is the y, which is a negative root 3 over 2. And again, cos of 300 in your calculator is 0.5, and the sine of 300 is a negative 866. So you can use your calculator, but it's nice to do it this way too. And when we put it all together and come up with this, let's see, I gotta get a ruler here. I got a ruler. If you put all these rotations together, and if we draw a line like this through the center, we're going to make, like we did in the previous one, we're going to make a butterfly or a bow. So here we go. They crisscross. So what happens again, this point is 1, 0. The radius of the circle is 1. The radius is 1. So what happens, this rotation from here to here is 60 degree rotation, and we drop a perpendicular, but because it's a bow, a butterfly, where it goes right straight down through. And it goes, remember, the perpendicular goes to the x-axis. So look at our butterfly, or look at our bow. So this angle This rotation is 60, so this reference angle is 60. So this is a perpendicular here. So that's a 30. So opposite 30 is 1/2. Opposite 60 is root 3 over 2. So what happens is that the x is a 1/2 and the y is root 3 over 2. Now if we rotate over to here, and let me rotate right here like this. If I rotate to here, then that rotation is 120 degrees, and that gives me a reference angle of 60, because it's 180, take off 120, perpendicular to the x-axis, there's a 30. So this is 1/2. This is root 3 over 2, but the x is negative and the y is positive. And so this coordinate, again, x is negative 1/2. Root 3 over 2 is the y. And when we go to this rotation, again, we're going to rotate right around. Here we go. Right around till we get to right here. And this rotation is 240. That was all what I'm doing. The 4 figures that I did on the previous pages, I'm putting them all together. So that rotation right here is 240. That means this is a reference angle of 60. That's a 30. Opposite 30 is a 1/2, which is negative. Opposite 60 is root 3 over 2, but it's negative in the third quadrant. So the coordinates of this point, x is a negative 1/2, and y is a negative root 3 over 2. And to go all the way around 300 degrees, which is the other one I did, here we go, right over to here. So that's 300-degree rotation. There's the terminal arm. This reference angle is 60. That's a 30. That's a 1/2. This is root 3 over 2, negative. Opposite 30 is a 1/2. Opposite 60 is root 3 over 2. But because we're in the fourth quadrant, the x is positive and the y is negative. Notice for the 60-degree reference, we always have 1/2, but it's plus or minus depending on the quadrant. And the y is always root 3 over 2, but it's plus minus depending on the quadrant. So that's the 4 rotations from 0 to 360 with a reference angle of 60. Okay, notice, again, repeat, when I did the 30-degree reference, this was root 3 over 2, and this was a 1/2, positive and negative. So in the 30 reference, these are switched, root 3 over 2 and 1/2. What about 420? 420 is too large, so 420 take off 360 degrees. Let's make it positive coterminal angle will give me a 60. So 420 would be all the way around 360 plus 60 more. So, but it's easier to plot the 60. So there's the rotation of, if you go 420, you go all the way around like that and keep going. But that's the same as rotating 60. 60 reference, perpendicular, 30, 1/2, root 3 over 2, and the cos of 420 is the same as the cos of 60, and you get a 1/2. And the sine of 420 is the same as the sine of 60, which is root 3 over 2. And again, check your calculator. Cos of 420 should be 0.5. The sine of 420 should be decimal 866. But these are the exact values. Note the exact values means you can't use a decimal. Well, you could use 0.5, but you can't use root 3 over 2 is irrational. So it doesn't, decimal doesn't repeat. And 480 degrees, well, if we take 480 degrees negative, and let's turn on the calculator and clear it. So I'm going to put in negative 480. That's rotating backwards, but instead of doing all that, why don't we just add 360 and then add 360 again to get 240 degrees. So that's the cos of 240, and that's the sine of 240. So instead of going negative 480 and negative again, why don't we just rotate this way to 240. Draw a terminal arm going out through. So that's 240 degrees, and 240 is 180 and 60. 30, that's a half. That's root 3 over 2. But in the third quadrant, the x is negative and the y is negative. So the cos of 240 is negative half. And the sine of 240 is a negative root 3 over 2. Check it with your calculator, and you should get negative 0.5 and a negative 866. Okay, let's continue. And now we're asked to do the individual ones. Find the exact value of each. The cos of 240. Well, we're going to do the cos of 240. Again, you can use your calculator, but I repeat, it's nice to draw the diagram. The cos of 240 on your calculator, if you put your calculator down, clear it, the cos of 240 is negative 0.5. So that's going to be a negative a half, but let's do it understanding. 240 is this rotation, 90, 180, and all the way over to here. So that's 240 degree rotation. Terminal arm, that makes this angle 60. The 180 and 60 makes 180. Or sorry, 180 and 60 makes 240. There's the 30 degree. This is a half. Opposite 60 is root 3 over 2. That's negative and that's negative. So the cos is the x, which is a negative a half. So if you use your calculator, you'll get a negative 0.5. And again, just emphasize, is you're rotating from this point. You're rotating to point 1, 0 up around the circle, and you end up with these two coordinates, and the x coordinate would be a negative a half for this one. And what about the 300 degree rotation? 300 degree rotation starts here, rotates all the way around the circle, and it ends up right here. And that 300 is 360 minus 300. That gives us a 60 reference. Perpendicular, 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And that's the x, positive, and the y is negative. And the sine is the y value, which is a negative root 3 over 2. Or if you use your calculator, you should get a negative 0.866, which I know is going to be negative root 3 over 2. And how about the tan of 300? Negative? Negative 300. Well, if you take the negative 300, and let's do it right here. Let's do it over here. If you take the negative 300 and you add on 360, you should get a 60 degree angle. So instead of going this way, which you can, you also can go this way. So there's the 60 rotation. So the tan of a negative 300 is the same as the tan of 60 degrees. Draw a terminal arm out through, perpendicular. This angle in here is 60. That's the 30. That's a half. That's a root 3 over 2. The radius of the circle, this point is 1, 0. The radius of the circle is 1 because it's a unit circle we're doing it on. So the tan would be the y over the x, which could be also the sine of 60 over the cos of 60, because sine is the y, the cos is the x. So the sine is root 3 over 2, and the x is a half, so that's root 3 over 2 times 2 over 1. The 2's cancel, and you get a root 3. Okay, hopefully everything is going well. And don't remember, you can pause your video at any time. How about the secant of 120? Well, the secant of 120 is 1 over the cos of 120. So 120 degree rotation on the unit circle, whose radius is 1. So this radius is 1, and we rotate 120 degrees, which is approximately, let's say, right there. So the terminal arm goes out through, that's 120. So if that's 120, then this is a 60, because 120 and 60 is 180, perpendicular to the x-axis. That's the 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. This is the y, which is positive. This is the x, which is negative. And so the 1 over the cos of 120, cos is the x on this unit circle, whose radius is 1. So it's a negative a half. And we have 1 times negative 2 over 1, or negative 2. Okay, let's continue. A couple of more to do. Hopefully you've learned the triangle. Again, just to repeat, you've learned that 30, 60, 90, special triangle, opposite 30 is a half, opposite 60 is root 3 over 2 and 1. And on the unit circle, cos of theta, the rotation, cos is the x, and the x is whatever it is in the triangle. So depends where, and sine is of the rotation is the y. I can't put a half or root 3 over 2 because I don't know the rotation. But let's try the cosecant of 600 is 1 over, cosecant is the reciprocal of sine, 600, and 600 is too large, so take off 360, and I should get sine of 240. So let's draw the circle. And again, remember, the point is 1, 0. The radius of the circle is 1. So we rotate 240 degrees. We rotate 90, 180, and 180 plus 60. So that's a 60 degree. It's a 240 degree rotation. Perpendicular to the x-axis, 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. This quadrant x is negative, and the y is negative. And the sine is the y. So the y is 1 over negative root 3 over 2. So that's 1 times negative 2 over root 3, which is the negative 2 over root 3, times the radical. So that's negative 2 root 3 over 3. And we rationalize the denominator when we have a radical by multiplying by the same root. Root 3 times root 3 is root 9, which is 3. And the cot of negative 420. So we take the calculator and take a negative 420. We turn it on, clear it, negative 420. We're going to add on 360. Still negative. Add on 360. 300. So the cot of a negative 420 is the same as the cot of 300. Now you could plot the negative 420 if you want, your choice. But if you plot the 300, you could do the negative 420, but you'd have to go like that and get a negative 60 and come to here. But if you do the 300, 90, 180, 270, and there's the 300 roughly there. So that's 300 degree rotation. And there's the terminal arm. Drop it perpendicular to the x-axis. And this is the 300, so therefore that's a 60 right there. That's a 30. Remember, that's a 300. As far as here, 60 more makes 360. So opposite 30 is a half. Opposite 60 is root 3 over 2. And the x is positive on this side, and the y is negative going down. So the tan is the y over the x, so the cot is the x over the y, or it's the cos, which is the x, over the sine, whatever way you want to learn it. But the x is 1/2, and the y is a negative root 3 over 2. So that's 1/2 times negative 2 over root 3. The 2's cancel, and you get negative 1 over root 3 times root 3 over root 3. And negative 1 times root 3 is negative root 3. Root 3 times root 3 is 3, or square root of 9, which is 3. And that's the exact values. So that's dealing with when you have a reference angle of 60 in any one of the quadrants. And hopefully you understand the first video, which is the reference angle of 30. Second one, which had a reference angle of 60. And if you learn the triangle, a half, root 3 over 2, and the right triangle opposite the 30 and the 60, then you should never forget. And you also know in the quadrant where the x's and the y's are plus minus. And if you like my video, click on the like button, the subscribe button, notification bell, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.